Did you know a small narrow stream of air like this can crush these containers? I will be conducting 3 experiments crushing these containers, and at the end of experiments I will visually explain what happened during the experiments. The concepts in the experiments apply to many of my upcoming experiments, which visually applies Bernoulli's principle to real life situations. Hi, this is Charles, the Visio Educator. This is the second in a series of experiments applying Bernoulli's principle. Since Bernoulli's principle involves fluids, and if you're not familiar with what is meant by a fluid, go now or later to this link where I visually define a fluid. I will be doing an experiment showing how a narrow stream of air can create a vacuum. To those of you who are not familiar with what is meant by a vacuum, here is a good visual example. The lady is pumping out the air in a sealed bag that contains clothes. As the air is being pumped out of the bag, a vacuum is created, and this can be seen on the bag as it gets more compact. What is meant by Bernoulli's principle? Bernoulli's principle states when a narrow stream of a fluid increases, such as air, the pressure within the narrow stream of air decreases. Also take note during the experiment, the fluid air has minimal movement at atmospheric pressure. Atmospheric pressure is a high pressure. The fluid air will be used in 3 places in this experiment. The first, at atmospheric pressure inside the container. Second, air at atmospheric pressure outside the container. And third, a narrow stream of air flowing out the tube. Now let's get on with the experiment. I'm going to apply a narrow stream of air, fast moving air, through this tube right here. Wow, it's squished. Now let's try a bigger container. Wow. Now we're going to see one more before we explain the experiment. Now let's see what this tin can, what it'll do. Wow. What happened in the experiment? The narrow stream of air passing through the top of the tube creates a low pressure. The air inside the container is at atmospheric pressure, which has a high pressure. The low pressure stream of air along the top draws the high pressure air from the bottom of the container up to the top of the tube. And when it gets to the top of the tube, the fluid air mixes with the narrow stream of air, and it goes out this way. As the high pressure is removed from the inside the container, a vacuum is created. Outside the container, the high pressure atmosphere pushes inward on all sides of the container. See? If you like this video, go to my next video, The Value of Air, which applies concepts learned in this video to real life examples.